Hi, Tim.
Hey, hello. How are you?
Good, thank you. I was going to ask you where you're from, then I noticed the t-shirt.
You noticed the T-shirt? It's kind of a dead giveaway there, huh?
Just a little bit, but I like it. Cool design. Cool logo, I should say. The no bark, no all bite.
No bark, I'll bite. Yeah, I'm about a half hour south of Cleveland.
Gotcha. So in
Yep. How about
Econite,
yourself? How about yourself? Where are you from?
I'm in the southwest suburbs in North Royalton, to be specific.
Oh, you're North Royalton. Oh, okay. You're in my neck of the woods. I'm in Brunswick,
Oh, okay.
so you're just a little bit north of me.
Yeah, not too far.
Yeah.
Weather's been kind of crazy lately.
Yeah. Cooled off quite a bit. Yeah, it did.
Yeah, I mean, this morning I woke up, I'm like, do I have to turn the heat on? I was a little concerned, and then it warmed up significantly throughout the day.
Yeah. Yeah. We're supposed to get some rain tomorrow. We do need it. I mean, it's been kind of dry.
Yeah. So what kind of stuff do you work on?
Well, I'm kind of semi-retired right now. I guess when I joined this group, I put down that I'm more like a hobbyist.
Okay.
Okay, but uh, I used to. I retired back in 21, and I used to be a electrical computer engineer.
Hmm.
I did that for like about 30 some years. And the last project I was on, in fact, the last couple of projects I was working on, I was doing some programming in C sharp.
See.
Did some did some software programming with C sharp, and so I have some ideas about like enhancing some of that software that I worked on. When was looking around for different groups, this one kind of intrigued me because I kind of liked the C sharp environment there. I was
Hmm.
working with. Yeah, I worked on that for several years with several other software engineers, and so I kind of got intrigued by the C sharp user group, And
Yeah, it seems like no matter what engineering discipline you're in, you always end up doing some kind of coding.
yeah, I did kind of gravitate toward that. Yeah, it could because it seems like there's more of a demand for coding, I guess.
Hmm.
Yes. Well, they're always changing the software, but it's harder to change the hardware.
Exactly. And that was my main reason. I also started out in computer engineering at Cleveland State to be
Hmm.
more hardware based and more of an electrical engineering curriculum. But then about a year before graduation, I switched to computer science with a double E concentration. And I found that everyone that was graduating and working, they were doing or steering more into software development for that simple reason. The motherboards and the hardware are pretty standard, and then you do the customization all through coding. So that's where the challenge lied, and that's where I kind of steered my wagon, if you will.
Hmm. So, what kind of coding do you do now?
Uh, Now it's mostly AI and machine learning. However, I stay within the Microsoft space. So I utilize C Sharp and the machine learning.net framework. And then in some cases, I work with TensorFlow. And then, of course, SQL Server database as well and Azure. So I'm pretty comfortable in the Microsoft space.
I see. Yeah. So you're a little bit higher level than I was. I was more a lower level. I was kind of a nuts and bolts kind of person with my programming. I would like capture data. It could be from sensors, or
Hmm.
from whatever, and put it on a network. It either could be an Ethernet network, CAN bus network, or is a Motion network I work with sometimes. And well, I would just capture data and then I would give it to more like a higher level software person.
Yeah, I did a
I
little bit of
wasn't
that
a
as well.
data. I wasn't really the data processing type of person. I was more lower level, nuts and bolts,
Yeah,
or like networking protocols.
I see.
The programming I did was more like that. You know.
It's all very interesting. Do you ever work with assembler? Did you get that low level?
Yes, I did. I
Nice.
programmed some microcontrollers. I did some assembly language programming, especially back in college,
Hmm.
and I had
Yeah, that was
some.
the last time I touched assembler was in college. But I like getting down into the weeds and having full control of everything. That was cool.
Yeah, that was kind of my. I did some of that similar stuff programming. I did some C programming. I did some C++ programming, and I've done MATLAB
Yeah.
programming. And let's see, I've done C sharp. But yeah, it
Well,
seems like
we won't be doing a whole lot of C sharp tonight, but we'll definitely going to be discussing machine learning and some of the key concepts behind the data cleansing for machine learning. Um, so, with that said, we are at a little bit after 6 o'clock. So, let's go ahead and get started. I'm going to go ahead and start the recording.
This conference will now be recorded.
Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C Sharp User Group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. As always, a big thank you to our sponsors, the .NET Foundation for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space. If you're joining us for the first time, first of all, welcome. Glad to have you. And please keep in mind, participation is encouraged. Like I always say, the only stupid question is the one not being asked. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning feel free to jump in at any point in time with a question or a comment. However, we want to ensure there's enough time for all the presentation slides and the demos. Lastly, the presentation is being recorded and will be posted on YouTube in just a few short days after the editing. So for tonight's feature presentation, it is Data Cleansing for Machine Learning, brought to you by yours truly. You can find me on Twitter at Sam Nasser. I've been a software developer since 1995, and I'm a senior software engineer and trainer for NIS Technologies. I've been certified with a few certifications from Microsoft, and I run the Cleveland C# user group, as well as the Azure Cleveland user group. I've also been a technical author, both in print and recorded videos, and I'm an 8-time Microsoft MVP. A little shameless plug for the user groups that I'm involved in the Cleveland area. These two groups, the Azure Cleveland user group and the Cleveland C# user group, meet every month. Those meetings are free of charge and open to the public and all expertise levels, whether you're a hobbyist, a student, or a working professional. You can find all the meeting information for both Azure Cleveland as well as Cleveland C# on meetup.com at the links listed on the bottom of the slide. These links will be accessible through a QR code at the end of the presentation. So without further ado, let's jump into it. So first and foremost, why should we bother with data cleansing? Well, like the old adage, you want to avoid garbage in, garbage out. So we want to ensure that the data we're feeding our machine learning model is accurate, and it will help produce a more accurate model. This process is the most time-consuming of the entire machine learning process because there's a lot of, depending on the type of data that you're starting with, but there's going to be a lot of manipulation, a lot of validation, and it's a rather time-consuming process. One of the things that we want to consider is were all options equally visible to the user, meaning if we present the user with a set of options, are they all equally visible, or is there some kind of a hidden link or something else that might steer the user towards guessing or picking a value that we want them to pick? We want them to be able to pick a value freely without influencing them one way or the other. To demonstrate my point, let's take a look at the sample website. And as you see here, sometimes when we're reserving airline tickets, we're presented with these options. So as a user, and specifically if you're in a hurry, which option are you likely to choose? And I would like to hear from the audience. Feel free to jump in. So which option are you likely to choose? Many people would, oh, sorry, you're not seeing my screen. Let me do that again. There we go. Sorry about that. So if you're presented with options like this, what are you likely to choose? You have the first class for an additional $250, business class for an additional $100, and Econo Plus for a mere $25. And I am sorry I interrupted someone that was chiming in.
Oh, I was just saying, third one.
The third one, the $25 option, right? It's the most economical. You just want to get the process over with. But for those that are very frugal, obviously this is the only option that you think is available is the $25 option, right? However, let me steer your attention towards the bottom of the page, and there you see highlighted where it says continue with standard seating, no extra charge. So this is a very deceivious way of steering the consumer to picking out a selection that they really didn't want, but it was kind of the lesser of the three evils available. And they just opted for the $25 option when they really would have liked to have selected the link at the bottom that said no additional charge. So when we're doing data cleansing, we want to look at the application and the data collection process first and see, are all options available to the user? Did the user freely select those items? That's number one. Going back into our slide deck, You want to ensure that users were not influenced by other factors. What do I mean by that? And this is something that I was actually actively participating in. We had 3 groups of volunteers, and we wanted them to participate in one of 3 activities that were going on. And we said to help encourage people to put their name into these boxes for these various groups, we're going to offer a $25 Amazon gift card just to entice people to participate. So what ended up happening, everyone put their name in all 3 boxes. And then when it came time to actually call them and get them to volunteer, we made the phone calls, we sent out emails, text messages, and the response was absolutely 0. So essentially, everyone was interested in the Amazon gift card. No one really cared about volunteering. And so, although we had good intentions of enticing people to participate, what we did was we influenced the users by outside factors, and essentially we got the wrong results in the end. The other thing to consider, has the data been manually entered or is it automated? Now, this is a factor in the sense that, if it's obviously manually entered, then you could be running into a lot of various problems because it could be fat fingered in, a value could have been accidentally left out, or a extra large value could have been entered in, maybe an extra 0. And so all these are things that we need to consider. In addition, when are we capturing that final value? So let's take, for example, the sale price of a home. Obviously, we want to train our model to be able to predict the sale price of a home. But if we're going to be training it on the sale price of the home, when was that sale price captured? Was it when the offer was made? Or was it when the actual papers were filed? Because sometimes you make an offer on a home, that offer may be accepted at first, but then later on the loan doesn't go through for whatever reason, and so it falls through, or maybe something is discovered about the home, and now we have to lower the price in order for the sale to go through. So the question is, when was the final price of that home captured? Was it on the initial offer? Was it the total price of the loan that was given out? Or was it the value that was submitted to the county in the final paperwork? These are things that we have to evaluate. And then, of course, although we typically don't return homes, like you don't come back to the bank with a receipt and say, I'm returning this home, but in some cases, you do actually return the merchandise that you have purchased. So in that case, then do we remove that sale price from our data, or how do we compensate for returns or reversing that transaction? So that's another thing that needs to be considered. One of the main reasons for machine learning or cleansing the data for machine learning is we want to prevent what's called overfitting. And what overfitting is essentially the machine learning model memorizes the data that it was given. And so to help prevent overfitting, we want to remove the noise and outliers, and we want to give it the basic trend, the happy path, if you will, of what are the most values that it's going to be trained on and what the final outcome is going to be in most cases. We also want to fix any inconsistent labels. So in the world of machine learning, you have 2 types of parameters, the input and the output. The input is called a feature, the output is called the label. So we want to be able to have consistent labels, and anything that's inconsistent, we certainly want to fix it before we start our machine learning process. The third point, we want to handle missing values wisely. There are many options that we're going to discuss on how we're going to handle missing values, and there are pros and cons, and it is probably the biggest it depends that I have ever encountered in my career. There are so many ways to maneuver down this path that it just depends on your own specific scenario. We want to move redundant or irrelevant features. So for example, let's take the home price model that we had talked about briefly. Obviously, some of the things that are important for determining the price of a home, the number of bedrooms, number of bathrooms, the zip code that that property is in. But then some irrelevant features may be the land square footage. Do we really care about that? Is that a big factor? Will it influence the price of the home? And we'll talk about this in more detail, whether the yard is fenced in or not. These are other factors that may influence the home, but in some cases, they're really irrelevant. It's not going to make that much of a difference. Another thing is we want to normalize and scale our features being the input value. So when we say normalize and scale, like here, for example, we're showing that $100,000 could be listed as 100K or 100,000 with 5 zeros trailing. We want our numbers to be consistent like that. We don't want it to be all over the place or mix and match. And I wanted to pause for a second and see, do we have any questions? And again, I encourage you to jump in at any point in time with a question, either verbally or in chat. But if there are none, then we'll keep moving forward. Another thing that I always like to emphasize is utilizing the subject matter expert or SME. So a common mistake that happens a lot is that software developer or a data engineer will start building the model before fully understanding the business. And again, going back to our scenario of home purchases, does that data engineer know what are the specific features that go into predicting the final price of a home? More importantly, you want to identify a specific object statement or objective statement. What is it that you're trying to solve? What is it that you're trying to accomplish in the end goal? Are you trying to predict the price given a set of features? Are you trying to detect any anomalies throughout the history of sales? What is it that you're trying to do by building this model? And so once you create that objective statement, then the subject matter expert can help you identify the key input values. So this SME is someone that obviously has worked in the business, knows the ins and the outs, and they can identify what other factors could influence the price of a home, for example. Another thing to consider is the time and date of historical data. So with machine learning, we always say more data is better, creates a more accurate model, which is true from a very high level, right? However, when you're taking home prices into consideration, for example, the date of when that home was sold will greatly affect the final outcome. So I could take one home, for example, that may have been built in the 50s, and I have data of when it was sold in the 60s and in the 70s, and then comparing it to utilizing data that was from last year. Obviously, the price of homes in 2024 is drastically different than what it was back in the 60s and 70s. So taking into consideration the date of that transaction may affect it in this case for home prices. However, there are some things that are not dependent on the date. Like if I'm looking at, let's say, LDL and weight of a person, that is kind of a linear type of model. And so it's not really dependent on date. Those are only the two factors. The LDL is dependent on weight or vice versa. LDL is your bad cholesterol, by the way. So that's not really dependent on the date, but rather that is a relationship that has remained true throughout history. So again, the SME can help answer that better. And as I mentioned, more records equates to a more accurate model. But more specifically, better context provides a more accurate model. Meaning, we touched on number of bathrooms, number of bedrooms, and the zip code, right? But there are a significant number of other features that affect the price of a home. For example, does that home have any termite damage? Did it have any water damage in the past? Is it in a low water table? There's a variety of other factors that could influence it. Is it located on a main street or a side street? So there's a variety of other factors that could influence it. So I can't just look at a specific set of features, but rather I have to ensure that it is within the entire context that could affect the final outcome. So when it comes to selecting columns for training, one of the things to consider is that every table that I look at, assuming it follows best practices, but every table in a database that I'm looking at will likely have an ID field or a unique identifier. So in most cases, this can be excluded because it really doesn't provide any specific information to what it is that I'm after. So obviously ID and unique identifiers can be excluded. If I am forecasting, again, dependent on my objective statement, what is it that I'm trying to accomplish? Do I need to drill down to the exact date? Or will a year simply suffice, or a month/year suffice for what I'm trying to do? Also, in some cases, I may want to look at categories as opposed to specifics. So for example, if I'm tracking home sales, do I want to look at the state that the home was sold in? Or do I need to drill down into the zip code or maybe even the city to help predict what the outcome would be? And as I mentioned earlier, the date, is it relative for each record? Do I need to take that into consideration? So essentially, my overall objectives when I'm doing machine learning and data cleansing is, first, I want to make sure the data is normalized. I want to ensure that any missing values, or I want to have some kind of a strategy for replacing those missing values. And of course, I want to remove duplicate data because I don't want to skew the outcome towards one value or another. So one of the things that I need to consider is the data type and the structure. So, and again, this depends on whether you're given the data as a plain old spreadsheet, or is it in a database that is actually properly formatted and it has the right data structures in place, meaning, and I've actually seen this, that there are tables where there are no unique identifiers and that every field is essentially a varchar or a string field. And so users are free to enter in whatever they want, and so we are not adhering to any specific data type. So for age, they would enter in the number 4, or in some cases, FOUR. So we are all over the place. So the first thing is you want to make sure that the data adheres to the data types. In addition, you want to check for data integrity by examining the schema. And sadly, yet this is another scenario I've come across. There are some clients where basically we have 2 separate tables. They look like they're related, where it's a parent-child relationship. However, you start drilling down into it, and there are no foreign key constraints that tie these 2 tables together. Rather, it is the implied logic that ties them together. Also, for my machine learning model, I need to consider what is a required field versus what is an optional field. So if I'm going to have a field as part of my feature set, then all input fields must be required. Otherwise, the results might not be meaningful and may skew the data into the negative direction. And let me pause here for a moment. Any questions so far? All right, onwards and upwards. One of the things that I also need to check, aside from the data structure, is the business logic that is behind it. I want to ensure that whenever I am populating a field, that it does adhere to specific business logic. So I want to check for things like medical procedures. A procedure that I may apply to a male may not be applicable to a female, or vice versa. Or in some cases, like if I have an automotive repair facility, is there such a thing as air conditioning maintenance on a motorcycle? Obviously not. It wouldn't apply. Also, things that are relevant to the particular time of the year or the seasons of the year. So I'm not going to have a snow removal service during June, July, or August. That's not going to be applicable. And I want to be able to scan for distinct values. So this gives me the range of all the various distinct values in my database. so that I can see that everything is represented, may not be equally represented, but I want to see that I have a span of various values that are entered in. Now, how do I deal with missing data? So first, one easy way is that I can ask, can it be reverse engineered? For example, if I have a first name and a last name field, and the first name is Sam, but the last name is missing, but I know that what that missing value is. Another thing I could do is I can substitute a custom substitution value and put it in. For example, 999 for a missing value. And so in the end, after I've trained my model, then that value will show how many records had those missing values, and it will be set aside. Another method is that I could replace it either with a mean, a median, or a mode. And we'll talk about those in upcoming slides, but those are different types of averages where I can populate them for that missing value. And this seems to be everybody's favorite option. Just simply remove the entire row, right? And this is applicable only when you have a small data set and it's really not worth fussing or spending the time on. It's applicable when we have a large data set, but only a few rows have a missing data. So for example, if I have a record set of 5,000 records and only 2 records have missing data, it is not worth my time to go through and try to decipher it or reverse engineer it or figure out those missing values using one of those algorithms. It's just easier to dispose of those 2 records and move on with the other 4,900 plus records that I have. Another option is the principal component analysis or probabilistic component analysis, so PCA or PPCA. So these are algorithms and they are very math oriented, which we're not going to dive into it tonight, but essentially utilizes a lot of linear algebra and statistics to be able to dive in and calculate what is that missing value based on all the other dimensions or features that are provided to the model. Pardon me. So looking at one of those additional or one of those features is MICE. What MICE stands for is multiple imputation by chained equations. And what happens is basically we go through a linear algebra type of algorithm where we take all the features, we take a guesstimate at what those missing values are, and then we recalculate it using those missing values and then adjust accordingly. So that's why you have multiple imputations through chained equations where essentially you're redoing it and rehashing it over and over again. So this is a powerful iterative method that models each variable with the missing value that we think we have a proper substitution for. And basically it creates multiple data sets by repeatedly guessing what those missing values are. So this is ideal for complex data sets. And the best way to explain it is by going through a demo. But for this example, we're going to look at a data set where we have age, income, and education. And in the income field, we're going to have some missing values. And then we're going to implement MICE through Python code. And this is where it's going to fill it in with the mean value at first. And then it's going to calculate the missing income dependent on age and education. And so it imputes the missing income value based on the model that it developed through that multiple iteration. Afterwards, it models the education using the age and the income, and then imputes the missing education values. So basically what it's doing is it's taking into consideration the 2 columns that are being provided, which are age and education. We calculate income, and then it goes and does the same thing, except this time it looks at one of the other columns, such as education, for example, and then it recalculates it again. It's rather difficult to describe it. And so what I always like to do is just simply demonstrate it. And more specifically, we'll go through a demo. And this is going to be utilizing Python code. And what we see here is that I have Databricks running. And Databricks is just basically going to be my framework for executing the code. And I will go through and we'll pull up the mice example in a notebook. And by show of hands, virtual hands, how many are familiar with Databricks? Okay, not a problem. The presentation tonight is not database. It's not Databricks targeting. What essentially Databricks is it's an ETL platform that I'm using mine through Azure. And what it allows me to do is to be able to have code. And in this case, I'm using Python code where I will execute it in this cell. So I don't need Visual Studio. I don't need any of the other development tools. Everything is web-based and it's running within this portal. And so if we take a look at the code, basically I am importing a couple Python libraries. I then have my data set where I have the age specified, income, and education, number of years of education. And if you'll notice, there are not a number of values that are listed here in the income. So I am deliberately creating a data set with missing values. What I'm doing then is I'm going to print the original data with the missing values. Then I'm going to set up my iterative imputer. And what the imputer does is it plugs in values and it will execute it for a number of 10 iterations. Then I will take the data that is specified here. I will plug it into my transform, which will essentially train that imputer. And then I will print out the imputed data afterwards. So I will go ahead and run the cell. It'll take just a moment. So we see the output. Basically, the first few statements are showing that it had imported the Python libraries that I had requested it to. And then we have the original data displayed. So someone at age 25 with 12 years of education makes 50,000. Someone at 35 with 14 years of education makes 70,000. And someone at 45 with 20 years of education makes 90,000. Obviously, there are two missing values in here, but then it imputed those values. It ran through them multiple times using the mice algorithm that's accessible to me through the Python libraries. And then I was able to output the value at the bottom. And as you see, it was able to derive a very good algorithm in the sense that it came up with a value that seems to be a good fit. Because at 25, we have 50,000. At 35, we're making 70,000, but a 30-year-old is now making 60,000. Same thing with the missing value for the 40-year-old. It found a good value that lied right in the center. So we have a nice linear regression of the age and income. So that's one method of filling in the values. Any questions on this? Go ahead, Aaron.
This be done through a Juniper notebook as well on Visual Studio Code?
Yeah, essentially it's Python code. It's just the framework where I'm running it is in Databricks. But yes, you can take that same Python code and execute it elsewhere.
Thank you.
Sure. Any other questions or comments? All right, very good. So moving right along. So when we talk about a custom substitution value, we talked about possibly fitting in a value that we're making up, something that is extreme, either a negative 999 or just simply displaying it as quote unquote unknown, but at least filling in that verbiage. The key is we don't want to use an existing category. We want to have it something that is going to be on its own and will be obvious that it's a new category. In some cases, we want to leave it missing. And that's where the missingness, if you will, has a actual meaning. So for example, if I give you a survey form, which I always do at the end of every presentation, if there's a question and you choose not to answer it, no response is a response. And so I shouldn't force fit a value into that, but rather accept it as that no response has meaning. So one thing to note is if I plug in a custom substitution value, like all nines or unknown, by using decision trees, random forests, or gradient boosting, all these algorithms handle it very well by keeping that value set aside or identifying it as a separate value. Now, if I use the standard imputation where I plug in an actual value using either a mean, median, or mode for average, this can introduce a bias into the system, especially if I have multiple records with missing values. Just simply making the assumption that I can use an average could introduce a strong bias into the data. And by utilizing a custom substitution value, it allows me to preserve the row count. So, depending on which algorithm I use or which method I use, now I can preserve that data set. So let's say that I have 5,000 rows, but literally 2,000 of them have missing values. By utilizing these custom substitution values, I can now train it on all 5,000 rows instead of having to disregard a good portion of them. And of course, by utilizing a custom value, it avoids the mistake of making assumptions about the distribution and essentially causing it to be biased. So we talked about the various means of calculating an average. And if you remember back from algebra class, there are three types of averages. So given this data set that we see here, we have 2, 3, 3, 4, and 100. Obviously, the number 3 is duplicated there twice intentionally. So if I was to calculate the mean is essentially adding in all the numbers of my data set, dividing them by the number of data sets that I have. So in this case, it's 5. And when I add everything up and divide it by 5, I get a value of 22.4. The median, on the other hand, is the middle value. So since I have 5 values, I will count 1, 2, 3, and the middle value is the number 3. And so that is my middle value. Mode, on the other hand, is the most frequent. So which number repeats more often? And that is the number 3. So in this particular case, median and mode are identical. Pardon me while I grab a quick drink. And so there are pros and cons depending on which one I use. So if you look at the mean, that is very, it can be influenced by outliers. So in this data set, my outlier is one value, which is 100. And as you see, the mean is 22.4 in comparison to the other averages, which is 3. And so it's heavily skewed because of that one single outlier. If I look at the middle value where the data is stored for a median, then the best use for that is when the data is skewed or has outliers. So because I'm looking at the middle value, I'm essentially excluding the outliers and focusing more on the meat of the data set or the middle portion of the data set. And then, of course, with mode, because it's looking at the number that is repeated or most repeated, in this case, it's the number 3. So it looks at the repeated value, and so therefore it is also not sensitive to outliers. So again, because I have a value of 100 in my data set, that is excluded from the mode altogether because I'm looking at the more frequent or the more repeated number. All right. So if I replace with a mean, it fills in the missing numerical values with the features and the average. However, it's quick and widely used, but it is sensitive to outliers. And it can reduce the data variability if the missingness isn't random. If I replace a missing value with a median, then obviously I'm using the middle value, and it's more robust to outliers compared to the mean. So this is excellent for skewed data or non-normally distributed data. Likewise, if I replace with mode, this is also ideal for categorical data because I'm looking at the category itself as opposed to the actual number or an outlier. And I would impute the most frequent category, meaning the one that is used often. So this can also skew the distribution if you have one category that is already dominant. So because one category is dominant, I am not equally representing all the other categories. I am simply plugging in the value that is repeated most often. Another option to consider is removing the entire row. So this is effective when the number of rows is relatively small, meaning the number of rows that I'm going to be removing is small in comparison to the record set at large. However, this can lead to a loss of valuable data, especially if the record set is small. Another thing that I always like to point out on machine learning projects is you want to track the number of rows that you have total versus the number of rows that you had removed for whatever reason, whether it's missing values or just could not be processed. You always want to document that with every machine learning iteration. Another thing to consider, and this is mostly dependent on what the subject matter expert would recommend, we can discard an entire feature if the missing data dominates. So if we have, let's say, a large number of records that have missing data for a specific column, and that column is a feature, we might want to disregard it completely. But again, that is something the SME would help to guide on. Also, removing the entire column is appropriate when the column adds little information. And again, this is only something that the SME can give guidance on. Keep in mind, it may also weaken the model performance if the feature was important. So if it's a feature that's important and we're utilizing that column, we're doing away with something that's important, so it's going to weaken the model accuracy overall. So PPCA, that is probabilistic principal component analysis. Now this is very interesting and it is very math heavy, so I'm going to try to keep it as high level as much as possible, but it is used to estimate the missing values, and it's especially useful for high dimensional data set, meaning that we have many features or variables for input that are available. And if we have many of those that are available, but we have some that are missing, this is where PPCA comes in handy. It is definitely more complex than its other cousin, pardon me. It's more complicated than its cousin, the principal component analysis. because PPCA is more probabilistic, and so there's more statistics that are involved in it. And let me jump ahead for just 1 second. Oh, okay. All right, so another thing to consider are outliers. So we'd want to inquire with our subject matter expert about the cause of the outlier values. So for example, if we, in a particular zip code, home prices are, let's say, between 400,000 to 500,000, but then we see one that's selling for 120. Why is it that that outlier, what has caused it to be such an outlier? We'd want to ask that. And then the SME may say, well, this has fire damage, insect damage, what have you. And so that's what caused the price to decline, which would then mean we would need to incorporate that as another feature into our machine learning. So a good way for detecting outliers, in my opinion, is utilizing data visualizations. At the blink of an eye, you'd be able to visualize the data and immediately identify where the outliers are at. You can also scan and do a min max for your data set to see the entire range. And like I said, if we have homes that sell between 400 and 500, when you're doing a min and a max and you see the min being 120, then obviously that's indicating that we have an outlier there. We also want to remove duplicate records as well as null values. Biases is another thing to consider when we're training a model. We want to have a good representation of all the candidate inputs across the entire spectrum. So like I said, number of bedrooms, number of bathrooms, or in some cases, we want to look at product sales for the entire week versus just certain days. So that way everything averages out as opposed to seeing a lot of highs and lows. So overall, you want to have a good overview of your data and be able to provide documentation for your team. And this includes things like the count, how many records have been processed, the unique values that have been processed, how many were actually missing. And then we want to provide things like min, max, and the mean deviation. So what this tells us is what is the type of data that we processed, any outliers or unique values, the range of the values that we processed during that machine learning iteration. Another key thing is to import the data into a relational database. What this allows you to do is, number one, be able to conform the data to a specific structure as far as the data types. In addition, you're also able to execute validation on it, meaning you can have check constraints, like as you see at the lower part of the slide, where I can check for the numeric range, and I can put check constraints that it lies within a specific range. Also, by importing into a database, if I have the right schema in place and I have the right foreign key constraints, it will help validate that the values for a foreign key are in fact attached to a foreign key table. Otherwise, if it's not there, then my data import would fail. So by importing the data from a non-relational into a relational database would help identify all those factors and be able to fit that data into the right scheme. Also, I want to standardize my numerical values. So am I displaying salary? Am I displaying hourly rate? Or am I displaying the amount of tips that is received, for example? I want to have I don't want to just say salary or wages and then be all over the place. I want to have a salary column, an hourly rate column, and then a tips column. So that way everything is more normalized. Likewise with the formatting, if I'm going to be training it on emails and phone numbers, I want to make sure that those values are also standardized as far as the formatting goes. And let me take a quick pause and see any questions or comments. Let me just gauge the audience. What do you think of it so far? I mean, is it too much information? Is it right on? Please give me some feedback. What do you think so far? And again, either come off of mute or enter into the chat.
Just, I think it's just right, but the thing is, I don't know that much about this topic, so I don't know who I am to judge. So,
Are you able to pick up something new?
yeah.
Okay, very good. Please keep in mind, feedback is always encouraged, as well as questions or comments. So with that said, let's continue on. So what are some of the data cleansing tools that are available? Obviously, there's a myriad of tools that are available out there. However, I'm going to discuss some of the more accessible ones that we have. Excel is a great tool, in my opinion. I consider Excel to be the Swiss Army knife when it comes to data manipulation. You can connect to a variety of different data sources. You can manipulate and transform the data, and it's a great tool. I don't encourage it as using it as a database or something to run your entire enterprise off of, but it is a great tool for having it on your desktop, doing some manipulation, and then importing that data or exporting it into a database. SQL Server Management Studio, another great tool. If you're comfortable with SQL, it's a great way to be able to execute the validity on the data, check for different constraints, import the data, can do a lot through Management Studio within SQL Server. Same thing can be said for Azure ML Studio, as well as Azure Databricks. And as you had seen, I had an example of Databricks, whereas I'm actually running Python code, but in addition, I could run either C# code. I can also be able to view my data, run various algorithms. And then there's the DQS, or the Data Quality Services. Although this is no longer supported in SQL Server 25, it is a great tool that's available in previous versions of SQL Server. And it's a great way to also manipulate and ensure the quality of the data. And there's also a plethora of third-party tools that are out there on the market. When using Excel, so it's very convenient for utilizing the data parsing features and removing formatting. You can also use it for spell check, also setting the case. You can use the trim function to remove spaces and also removing duplicates. And if you notice that for removing duplicates, I specify that that should be done last. Why do you think that would be? Why should we remove duplicates last after doing the trimming and setting the casing and the spell check and all that? Anyone want to
So
take a stab?
all the other stuff might create the duplicates or make them more apparent.
Exactly right. Thank you for your feedback. Yes, so I need to do that last because all the other steps might reveal additional duplicates, as Daniel said. And so that's going to be my last step. Now, just like everything else, it has its ups and its downs. One gotcha is that Excel can remove an entire column, but not the entire row. So meaning I can actually remove a column or remove cells within a column, and then everything shifts upwards. And now I have mismatching data, but I won't know that, right? So I can accidentally shift my data without knowing it, and that's the downfall, one of the downfalls of Excel. So let's take a quick look at some of these Excel functions. We can minimize these items. Let me go ahead and open up my demo. So I have a couple items here, and if you recall when I was talking about outliers, now if you're given a data set like this, how can you tell which ones are the outliers, right? I just see numbers upon numbers. It's not very easy, but I can highlight the two columns and then go to Insert, and then here I have a scatter plot and immediately draws the diagram for me And immediately at a glance, I can tell there are two outliers, specifically this one and that one. So it tells me the one with the weight is 410 and the LDL is 176. Okay, so this is a great example of using Excel. I highlighted two columns, click of a button. I'm able to create a scatter plot where I quickly identify where the outliers are at. Some other examples. Let's say I'm given a spreadsheet similar to this. It's very difficult to tell what needs attention and what not, right? But more specifically, if I go into here and I have some bad data, aside from me highlighting it, you probably wouldn't be able to tell what's wrong with these data cells. So one thing I could do is if I have a full name field here and I want to split it out, I can go over into one of my Excel functions and I can select data and text to columns. And here it's asking me, what is this column delimited by? So here I have a first name and a last name under name. And I'm going to say it's delimited by a character. In this case, it's a space. And as you see, it immediately separated the first name and the last name. So did this for multiple records all in one shot. Same thing, we're here, for example, I have occupation for someone that may be working two jobs. Pardon me. I may want to parse it out to show primary job and secondary job and parse those out into separate columns. As far as formatting, can highlight the column, select clear. Whoops, that removed everything. Let me backtrack and go back into body fat. And I can select clear the format and immediately removes the format that was already implemented for this column. I can also set for the case. So there are functions. Let's say that I need the last name to be all uppercase. I can select upper and select the cell. And there we see Howard all uppercase in comparison to the other column, or the parent column rather. Likewise, I can click and drag and immediately I have it for all the other cells as well. So for removing duplicates, like I said, this needs to be done last. And what I could do for that is highlight the entire worksheet. And then I go to data and remove duplicates. And where is it? Right there. Select that. And it's telling me which columns do I want to check for duplicates. And I can select those columns, and in this case tells me there were no duplicates found. But let's say that we want to go for first name, last name. So that would be columns B and C. And I would select remove duplicates, columns B and C. Okay. And here it found 61 duplicates and removed them from my table. Okay, so it's a great Swiss Army knife for manipulating my data all within my desktop, everything in one shot without having to worry about any records that I may have been left out. Any questions on that? All right. So essentially, what I'm striving to do is to be able to create a data validation pipeline. Now, obviously, I'm not going to go through all these steps for every machine learning iteration, but everything that I talked about here is essentially the building block for putting something like this together, where I receive my raw data, as we see on the far left. Then I do my cleaning, which encompasses removing duplicates, handling missing values. Then I want to validate it to make sure that everything falls within the business rules and the constraints. And then I want to document it or report on the number of records processed, the number of missing values that were either accommodated or removed. And then in the end, I have a clean data that could then be fed into my machine learning algorithm. All right. Any questions? And if no questions for me, then I always like to end it by asking you, what is it that we have learned here today? Did we learn about the new mice feature? Did we learn about PCA and how to handle missing values? We also talked about what are the various steps for the data cleansing process, how to handle missing values, either remove the row or use one of the algorithms that we talked about, using tools like Excel to quickly manipulate the record set that we have. So hopefully you were able to benefit from it and be able to come out ahead learning something new. If you need to get in touch with me, you can find all my contact information and social links over on Linktree. And more specifically, this is the QR code that I was referring to earlier. So there, this is the link to my Linktree. And within it, you'll have access to all my socials, the user groups that I had mentioned. More specifically, if there's any questions or comments that I can answer for you, if you're interested in having this as a class or as a lunch and learn for your team, I'd be more than happy to help out. You can email me directly, snasser@nistechnologies.com. All my socials are available on Linktree. And if we're not connected on LinkedIn, please, let's do so. It's a great platform for keeping in touch and finding out what others are working on, sharing information, and so forth. And so with that, if there are no more questions, I thank you all for attending and look forward to seeing you all at next month's meeting. Thank you, everyone.
Thank you.
This conference is no longer being recorded.
All right. Thank you, Aaron, Daniel, James. Thank you all for attending. Good night, everyone.
Good night.